Good morning, everyone. I welcome you all to this session on Introduction to Generative AI, Module 3. In the last module, we have seen what is data, the definition of data, and the different categories of data, which is the fuel for generative AI. In today's session, we will be more stressing on database, which is the backbone of generative AI. This is in reference with a non-technical introduction to generative AI. Welcome all of you once more. The content what we have here is the fuel of generative AI, which is basically the data which we spoke last week. The 7 V's of data, which defines the characteristics of data. Quickly, we'll walk you through that. The database evolution towards generative AI and beyond. When I say beyond, we will try getting into the year of 2030 and beyond, which is more to do with quantum computation. Let's give you a glimpse of that. Choosing databases, the backbone of generative AI, the different ways how data can be collected, which becomes an input to Gen AI, and the flavors of data sources for Gen AI. So this is the quick review on last session what we have seen. We have seen the categories of data, out of which I've just pulled out few as a review. We've seen synthetic data, which are artificially generated data using Gen AI. And we have also seen spatial data, which has a geographical content or a specific location of the Earth being specified, and also metadata. The metadata, as the name says, it's the data about a data. It gives us what is the file size of the data, what is the name of the data, where is it stored, the location of the storage. All this is what metadata is. Today, I have two more, main categories of data, which is the genomic data, which is important to know as this is about the DNA structure and the genes. This has been growing very rapidly in these times in the field of biotechnology. And obviously, the last one where I have from the categories of data is the dark data. Unfortunately, the data which is not used by the organizations or it has been not known by the organization is the dark data. The 7 V's of data. It starts with volume. It says that the scale of huge scale of data is what is expected under the generative AI. Variety, the different types of data should be supported. Velocity, the speed at which the data is created or collected. Veracity, the accuracy of the data. Value, what value does it bring in? The effectiveness or the usefulness of the data is what it speaks of. Variability, over time, how data changes, the change in the data, the frequency of the change, and visualization obviously is the graphical representation of data. So these any data, any categories of data are classified based on these 7 V's. Now let's get into what database is and the evolution of data towards generative AI and beyond from the starting of 1950s onwards. Before we get into the evolution, let's understand what database is all about. Database is a software that stores or manages data for any further insight, retrieval or prediction. Yeah, so it's basically a storage unit, which when we did understand what data is, we know to collect it, so we need to store it as well, right? So that's where the database comes in. If you see the evolution way back in 1950s to 1960s is where we started off, how data can be stored. We use file systems those days. Then 1970 came the relational database, which is XQL. Most of you might have seen that. 1980s, the commercial relation database, RDBMS is what got introduced. 1990s, which was the object-oriented databases, OODBMS. 2000, we have the NoSQL and the big data coming in. You might have heard of databases like MongoDB and Hadoop were the ones which came out in these times. 2010 where the cloud databases like AWS, Google Cloud, Microsoft Azure got introduced. 2020 is where the AI optimized database was introduced. That means it could understand better of predictive models. Advanced analytics could be generated with AI ML integrated onto maybe the cloud premises. Yeah, it also had real-time analytics like Apache Kafka, and stream processing platforms were introduced. That means on the fly, the data could be analyzed. Today, we stand in 2024. we talk of generative AI. What is generative AI? Basically speaks of scalability. It also speaks of integrating with AI tools, and also to support different types of data. We've seen the data type of data in the last thing. One of the examples which I have here is Google BigQuery. The next slide opens up what are the different databases we can use for Gen AI. Before we go into that, let's brush upon what the future direction is all about from a database point of view. It talks of quantum computation. To give you a very high level view, it's a shift from uh, uh, s- um, a classical computation to a quantum computation. That means we are trying to move from silicon based to an atomic based kind of computation, where the computational power is much higher, speeder, and quicker for computation. So that's where the future is. It's expected to see the light of the day starting from 2030 onwards. Now, let me now open up the 2024. What are the databases which the Gen AI would support? So these are the six things which are very on the top six, which is available as in today. The first one, we starts with Google BigQuery. Then we have the Amazon Redshift, the Azure Snipes, the snowflakes, the Databricks, and the Neo4j. So these are the six main databases which can be used by Gen AI. Before getting to this, let's understand what are the characteristics, or on what yardstick do we choose these databases for Gen AI. The first one is scalability, should be able to handle large data. Performance, obviously, high speed data retrieval should be, because it's a huge amount of data as well. Integration with AI tool, compatibility with artificial intelligence, data veracity, or support for diverse data types, real-time processing on the fly it should be able to. So based on this is what each of these characters are the ones which helps us decide what database should we be pick from the available Gen AI databases. So let's open up the first one, the Google BigQuery. This is known for the large scale data processing, and it features on real-time analysis, SQL-based queries, and it also has a scalable storage. The integration, it is easily integratable with modules like TensorFlow and Google Cloud AI. So the projects which are running on Google, obviously becomes easy for someone to adopt a BigQuery, when you're pushing projects from AI to a Gen AI. So that's what one of the yardstick which we can rely on. Makes easy. The second one is the Amazon Redshift, large scale data analytics is what the characteristics is. We have a module called as SageMaker, which is used for development and deployment of Gen AI. And this features as a massive parallel processing is one of the main points, or the advantages which the Redshift has comparatively. The third one is the Azure Snipes. Here, this the characteristics here is combining big data and the data warehouse entities. That's where the Azure Snipe stands for. The fourth one is the Snowflakes. This is known for large-scale data analytics and real-time data processing. It features multi-clustered shared data architecture. It's a near unlimited storage and supports for semi-structured data. We've seen what different structures of data are: semi-structured, structured, and unstructured. So when using more of semi-structured data, so this becomes a yardstick for us comparative to the other database available. The integration is compatible with TensorFlow and PyTorch. The fifth one is the Databricks. This is the platform powered by Apache Spark. This is high performance data processing, and collaborative notebook is what it knows for. The last one is the Neo4j, is a graphical database. When I say graphical database, this is applications where relationship and network analytics comes into play. So I'm trying to social networking. Say for example, Facebook. How different users are connected socially using this social network. So that's where the graph comes in. And when we need these kind of social media kind of a data coming in. So Neo4j can be handy. So we have understood the databases. Let's understand how do we collect these data. We know what data is. We know where to store it. How do we collect this? Some of the very common ways where we can collect data in terms of Gen AI is one is the web scraping, which we have known in the last version of artificial intelligence as well. We collect data from websites using modules like Beautiful Soup, Essence Scraper. We have a lot of them. The one of the hurdles what the web scraping is, please be aware of the copyright protection. It could be biased as well, and exposure to the lawsuit. So that's to be noted. The second one what we have is an API. Data can be collected using different API platforms like Google, Twitter. The public data we can have UCI machine learning repository available. Then sources like Kaggle can give us the manual annotation. We have Microsoft Forum. You can have a survey which is floated out using Microsoft Forum, a crowdsourcing platform, and from experts as well. We can collect data. The synthetic data, this is another thing. So this is something new which you should keep in mind. Generative AI, the capability of the generative AI is to create synthetic data, right? So synthetic data creation using Gen AI also becomes a possibility for us, which gets added into collecting data for AI. This is a pretty interesting slide, and these are the data sources where we can get data for our model, Gen model. So here I have categorized here into text-based sources or image, data sources. That means someone who's wanted to work on an NLP kind of a thing is what he would go for text-based sources. So we have similarly images. You want to use on computer vision. Where do I get data sources which are reliable and handy? So first one we have is a common crawl. This is a web data for news stories from websites across the globe. It's a language model. Your text data sources can be retrieved from here. Then you have the US healthcare. This is the healthcare organization which keeps track of drugs and diseases. That's a huge repository of the data. IMF data. Um, this gives in the International Monetary Fund. This gives the details about foreign exchanges, commodities, interest rates, globally. Then we have news data set. This is basically to do with newses across the globe, like BCC newses and other newses archive can be retrieved from here. MNIST, this is Modified National Institute for Standards and Technology database, and this is the one of the largest database for handwritten uh, single digits. IMDb, this is where we understand the movie reviews can be retrieved, and these are the databases which stores that and has a 25,000 plus reviews for training our models. Wikipedia, this is a comprehensive multilingual encyclopedia for that matter, which are huge amount of data sets. Apollo Scrape, it's a 3D, perception of a lidar, objective detection and tracking, largely used for autonomous driving. When I say lidar, light detection and ranging. So this is, it can give us basically in an unmanned vehicle, it can give us database which describes the density of the traffic at a particular place, the amount of bikes, amount of pedestrians, what is available. So it gives us that kind of a, database. The next one which is we have is a book corpus. This has 11,000 plus of free books which are there, novels, and the this data set is used for the GPT-3 models which we have been all using for quite some time. The OpenAI GPT-3, it is training large, language models is what it is used for, NLP. ImageNet, labeled image you have for computer vision. Then we have data.gov. This is the government database which has 241,000 plus of databases, which has basically to do with energy, climate, healthcare, education. All these gets accumulated under data governance as a database. Open web text, this is again a composition of millions of shared URLs. So if you would wanted to, get a repository of URLs, this is the place where one can go. US healthcare, I think that's an repeated one. Sorry for that. The Flickr and the Instagram. This is used for scrapped diverse image database. Computer vision can use this. COCO. This is a common object in context. This is labeled image for object detection. Uh, Project Gutenberg, over 60,000 plus of ebooks, which helps NLP and build LLM models using Gen AI. That's where one can go. Google's Open Image, 15.8 plus millions of labeled image, basically for computer vision. So that's a huge amount of repository where one can, according to what he's working on or he or she is working on a particular project, one can go to fetch these data, from a text data sources or an image data sources is basically I have, and then there are few which is of general database. Some move from this is audio data sources, and I have included video data sources and synthetic data sources. Yeah, synthetic data becomes important for us. Yeah, so Libre speech, this is a speech to text conversion kind of a thing someone would want to. This is the database one can go for. Then we have a Google audio set. This is a sound classification, audio event detection. These all can leverage data from a Google audio set. YouTube Atom, this is the large scale of labeled database, which is basically video classifications, the whole repository of YouTube. And then we have Kinetics. This helps, the database with, this gives database with human actions in video clips. That means human action recognition is kind of an application people could go for Kinetics. UCIML repository. This is a domain-based theory used for researchers, basically in the machine learning. Then we have Kaggle database. This is a community database where people can get on different communities. Then we have procedurally generated. This is where the synthetic data can be generated, can be retrieved, generated using algorithms to create these synthetic data. Then GAN generated, yeah, generative advisory networks. This is created. This is the created synthetic data using GAN is what this repository has. A medical data set, DMI, MIC3, NIH, and then we have the chest hex, sorry, the chest X-ray, medical records, data sets can be retrieved from medical data set. Financial data set, obviously we can use financial forecasting and algorithm trading. All these people could go fetch financial data set. The DCS is the digital corpus for Sanskrit for model tuning. So I've taken some of the language a translation kind of channels which is of a particular region. Then we have SARIT, digital repository of classical Indian text. So these are some of the the repository of data set where one can retrieve for their Gen AI. With this, thank you so much, and value your valuable time for your module 3, and see you in the next module. Thank you very much and have a wonderful rest of your day. Thank you.